All right, so last example that we have here, example number 5. Like I was kind of prepping at the end of the previous video. I was saying that this 5th example is actually probably the easiest, in my opinion, for what it's worth. The reason I would say that is that we're basically just, the biggest key to success, I suppose, in this problem is to recognize in reverse, basically, which formula it is that we're using. So usually it was a case to where it was like, all right, I have a 75-degree angle and I have to create that using my unit circle angles. So of my 16, how could I create a 75-degree angle, which is what we did previously. This time it's already all done. It's all created. What we need to do is we need to figure out which of the 6 sum and difference formulas do we actually see here. So if it's bothering you to see the 42 degrees, and I don't know what happened to my degrees, that was 42 degrees, 12 degrees, 42 degrees, 12 degrees. Again, let's not let that throw you off. But what we have, this is saying like the sine of u times the cosine of v minus the cosine of u times the sine of v. That's what we're noticing. So our first task is to figure out, okay, well, which of our formulas do we see here? Well, we know it's not a tangent formula, because again, those tangent formulas, they turn into fractions, and plus, frankly, they have tangent involved. So again, the thing that we want you to notice is that it's going sine times cosine. It's not cosine times cosine. So for that reason, we do know that it is a sine, and in this case, it's the sine of u minus v. So what we're saying is that this piece that we were given, that is the sine difference formula. So now we're going to, again, like from step 1 to step 2, to try to simplify things, instead of looking at things in terms of 42 degrees and 12 degrees, we started calling it u and v. So I suppose what we were doing is we were allowing u to be the 42 degrees and v to be the 12 degrees. So I don't know if it helps us to see it. We allowed u to equal 42 degrees while allowing v to equal 12 degrees. But guess what? It's time to substitute back into place. So we said that we're using the sine difference, so sine of u minus v, but in place of u, yeah, we're going to allow 42 degrees. And in place of v, we're going to allow 12 degrees. And luckily, yeah, we have the ability to subtract, and we know that this is going to give us the sine of 42 minus 12 is 30 degrees. And at this point, we actually know the sine of 30 degrees. So with our knowledge of the unit circle, we know that the value of the sine at 30 degrees is going to be equivalent to 1/2. So what you're going to notice is that with problems like these, each of the problems that is similar to this, the first task is to be able to look at what is given and determine, okay, is this a sine sum, sine difference, cosine sum, cosine difference, tangent sum, tangent difference? That's the first thing that has to happen. From there, it's a matter of, okay, what is u, what is v, plug in, and evaluate. And like I said, typically that's going to lead you somewhere that is a known spot on the unit circle. Now let's just say hypothetically that we had, again, totally changing the problem here. What if this were an addition? Well, if that were an addition, then that would have actually led to the sine sum formula. And it would have found us doing something like this, sine of 42 plus 12. And as we clean that up, the sine of 54 degrees. Well, that would have to be our final answer, because that's as exact as we're going to get. We don't know the sine of 54 degrees like we knew the sine of 30 degrees. Or we don't know how to break that apart any differently, frankly. So luckily, and I'll just give you that heads up right now, that's not going to happen. But if it were to happen, we would understand that not every single possibility is going to lead to a nice, I used my unit circle, so I got to this point sort of answer. But we sure like it when it does happen. All right, so remember what we said our goal was typically. It was a little wordy, but basically it was we can use the sum and difference formulas in various ways. So we were able to start with a given angle and break it apart into sum difference of whichever trig function. We were also able to draw our triangles to plug in. We're able to do like that last type of problem to where we were able to make that verification in terms of which sum or difference formula is actually being used, and then we can work backwards from that. So the homework assignment, the mandatory, can be found on page 379. As you can see, it most definitely jumps around. Again, jumps around an awful lot, quite frankly. But many of these questions, many of these problems are going to be relatively short, relatively simple. So again, we want to make sure that we're ready to go with this. So please come see me if you have any questions on this. But other than that, we're going to be ready to finish up Chapter 5 with Section 5.5.